So the first part of the problems ask you to draw a free body diagram of the system right here. So let's do that. So I'm going to talk about mass 1 first because that's easiest to do here. We have mass 1 resting on the surface. So therefore we have a force of gravity pulling straight downward represented by m1g. We have a normal force which is perpendicular to the surface pointing straight upward. The magnitude of normal force should equal to the magnitude of the force of gravity. Otherwise this box will accelerate through the surface. But that is not happening, so it balances out is equal to 0. Let's look at the x component right here. We have the force of friction is to the right. There's a reason for that because the object is moving to the left. So friction is always the opposite of the motions. So the object m1 is moving to the left, so friction is pointing to the right. We also have a tangent force because there's a rope right here, a string that's tying to mass 1. So I'm drawing arrow to the left. So this is pretty much a free body diagram for mass 1. Let's look at mass 2. So mass 2, we look at that mass 2 is going down the incline. So the friction force have to be the opposite of that, so pointing up the incline. So I'm going to label that force of frictions for mass 2. And I'm going to put a T stand for tensions. I didn't say T2 or T1 because the T should be the same because just one rope for mass 1 or mass 2. So I just put T without any subscript. We have the normal force. Is always normal force. It's resting on the surface. It's perpendicular to the surface. So as you can see, I draw that straight up from perpendicular to the surface right here. And mass 2 also have a force of gravity pulling down on it. And so I label that m2g. Alright. So if you observe very carefully, you notice how I have labeled that the vertical component, I'm going to call that the y-axis. And the horizontal component, I'm going to call that x-axis. The only difference here is I have the moving to the left as defined as positive. And it doesn't matter what coordinate system you use, whether you call x up or y horizontal, it doesn't really matter. The whole purpose of coordinate system is to help you solve problems. So you can use a different coordinate system, you will get to the same answer. I like to use it this way because it's more convenient for me to keep track of direction and things like that. As you can see here, I also say y is this direction, x is this direction because this box is moving this way. If it moves this way x, then this way down the incline is also referring to x2. So to simplify this, actually, yeah, so look, this is free body diagram. Do you need to draw all this dotted line? The answer is no. The reason I put it there is for you to kind of refer to just for reference, right? But the free body diagram should only compose maybe just the box and all the forces on it. Okay, it doesn't need all this dotted line. So let's move on to question number 2. It asks you about velocity, how fast the box moving for 1.2 seconds, right? So you always start out with find. What is it I need to find? So you need to have a sense, so you can have a sense of direction of where you're going. Whether you know how to solve the problem or not, you should be able to know how to figure out what is it that I need to find. I need to find V. Put a question mark, right? And then the next step is listen out the given, and in the problems, you just write down m1, m2, delta, mu, and starting velocity. V sub naught or V sub I is stand for starting velocity, is 0.07 meters per second, and it giving you the time. So some of you are probably wondering, why do I need to write all this find and given stuff? Well, it's easy for you to refer to when you actually solving the problem, right? You don't want to go back to the whole paragraph and read and try to find it. You can just simply look over to your list and just use it. So yeah, moving on. So the next step, we have drawing the free body diagrams for both masses. We have list find and given. So the next thing we need to do is you need to use Newton's second law, because this got to do with force, right? When we use Newton's second law, then we can find acceleration. When we find acceleration, then we can find velocity. So let's try that. Let's use Newton's second law. Oh, I forgot to talk about this. I just decided, you know what, I'm going to bend my coordinate system up a little bit like that. So it have the same as this one. So when it bend up like that, of course the normal force on the incline is now the vertical component. It's the y component here. The only thing that might look a little bit tricky here is this this force of gravity is because I kind of tilt it up like that. So so the force of gravity for mass 2 is at an angle. Okay. Yeah. So let's look through this. Let's just look at mass 1 first. We need to draw. Actually, we need to write an equation for mass 1 first. So we know that the sum of all the forces on mass 1 is equal to mass 1 accelerating, right? But to break that even further, we know that there is a tension force going this way. So we need to take T minus the friction force, okay? And again, I define left is a positive, so that's why T is a positive value, and then minus, this way is negative. That's how I define it. Then this become a negative. And again, you can use a different coordinate system and you will probably get the same answer too. If you're wondering what is mu n1, that's just the definition of friction, right? Mu is a constant, it's a number that's given often, like right here, and multiplied by the normal force, which is for mass 1 is m1g. So you can rewrite that and say, okay, tension force minus mu, normal force m1g equal mass 1 times accelerations. So we're done writing the equation for mass 1. Then we need to write equation for mass 2. It's the same process, right? We say that the sum of all the force for mass 2 is in the x direction, okay? I don't worry about the y directions because it's not accelerating through the right here, the box right here, it doesn't accelerate through the surface, or it doesn't accelerate upward. So it must be, the forces on the vertical component must be balanced, okay? The only thing I worry about is the x component, right, down the climb and up here. So that's why I write F2x. So this, let's talk about that later, but let's look at this force. So the force of frictions is mu times N2, normal force 2, minus the tension, right? And M2 sine of angle is down the incline, and this is something that you just need to remember, right? Down inclines is the mass g sine angle, and the derivation of that is in my previous video. You could watch how I come up with that, okay? But if you like, oh, I don't want to deal with all that mathematics to come up with the equation, then just remember that the force down the incline is m2g sine angle. All right, so moving on, let's see. So we have m2 sine angle, mu, the normal force. Again, the normal force here is not the same as m1. It is mg cos of angle. Again, and again, if you don't remember how where I come up with m2 sine angle and m2 cos angle for the normal force, check out my earlier video talking about how the normal force and inclines is mg cos angle, and the force down incline is mg sine. And again, watch that video if you're confused with that. But for now, just forget that. Just say, okay, so I have m2g sine theta is this force down here. So why is there a force down here? If you think about it, this is a vector, right? So it has an x component, and has a y component. So the y component balanced out with the normal force. The x component right here is mg sine theta, okay? So that's why we have mg sine theta here. And then so I plug everything in, it should be mass 2 times accelerations. Okay. So what next? Now I have the equation for mass 1 and of course equation for mass 2. So here's some mathematical trick to find acceleration. So I'm going to take the first equation, I'm going to add the second one. So I'm going to take the equation for mass 1 plus the equation for mass 2. The reason I'm doing this is because when I add them together, then I will remove the t. Okay, the only thing I'm going to worry about is the acceleration now. So if I add this first equation with the second equation, I should end up with this. So t plus minus t is 0, so I don't need to put anything down. Minus mu m1g plus 0 is equal to that. And then we have minus 2g sine angle, I just write that again, minus mu m2g cos angle. I put it down again. Again, I just add the top part with the bottom part. And over here, the equal sign, I have m1 acceleration plus m2 acceleration. So it becomes that. Okay. So I can clean up my algebra a little bit more and just pull out the a. And I divided by both sides by m1 plus m2. That will give me my accelerations. The rest is just plugging in a number, right? We have all this variable listed, and we have all that variable is a given quantity that you can put in. So now that we have acceleration, the last step is figuring out the velocity, right? What should I use, the two kinematic equations, or what should I use to find velocity? It's easier than that. Velocity, we start out with the definition of acceleration. Acceleration is defined as a change in velocity over time. So therefore, to find v right here, v sub naught is just a starting velocity. This is a final velocity. And then so we just manipulate the equation, put v by itself, and then that will give us the velocity. So let's look at this equation to see we have other given here. Starting velocity is a given quantity, 0.7 meters per second. The time is also given. The acceleration is something that you calculate over here, and you just plug that in. That gives us the final velocity. Okay. So that's a lot of stuff going on. You might not remember what is important here. In this problem, you just need to remember what's important. It's important to draw a correct free body diagrams and pick the coordinate system that best allow you to solve the problem more efficient. You can pick different coordinate system, you will get the same result. The second thing you need to do is list down find and given. Okay, and once you list down the find and given, you go into Newton's second law, as you can see here, to find acceleration. Go into Newton's law to find acceleration. Once you have acceleration, you can put into the kinematic equations, or you can put into just the definition of what is a, and that will get you to your final result. That's it for this problem. I will see you in the next video.